quantum mechanics was wrong. How might quantum mechanics break down? A lot of people thinking about that. There's a lot of kind of crazy theories that have been proposed for a long time. I want to tell you about one of them, which was resurfaced back just a few months ago and analyzed our data in the context of this theory. When we do physics, when you do engineering, we make fundamental assumptions about space and time. Homogeneous, isotropic, time progresses uniformly. But when you look at fine-grained scale, Planck scale, 10 to the minus 34 meters, you start to think that maybe space really isn't homogeneous. Maybe it's grainy. Maybe time isn't continuous. Maybe it ticks in a funny way on certain distance scales. And maybe quantum mechanics of massively separated objects might be sensitive to these kind of perturbations. It turns out we have to have extreme control over the paths of the atoms to get them to come back together and interfere constructively. And if the velocity of one of those wave packets changes by nanometers per second, that's enough to kind of wipe out the coherence. And so we make this experiment by the fact that we see those fringes makes very good tests of anything that's going to go in there and shake around the atoms as they're propagating. And it may be the very nature of space-time itself that's doing this. This Ellis model imagines a gas of wormholes that are flying through space, and this was taken seriously until the early 90s when some people shot this theory down. And these wormholes, according to this phenomenology, collide with the atoms and give small momentum kicks and ruin the interference pattern. And so there's a bunch of complicated math these guys did, and basically showed that the data I just showed you dramatically constrains these sort of wormhole theories. And to put these theories in context, there's been a lot of thought about the quantum mechanics of black holes and things recently and over the past few years. And this was one of the early types of forays into quantum gravity by people